A Laplace transform table visualizing the time domain functions. Here is a Laplace transform table with the time domain functions on the left and the corresponding S-domain functions on the right. Let's visualize each time domain function. This is a step function. It's a unit step function because the amplitude is equal to 1. It begins at t equals 0. This is an exponential function. A is equal to 1. It grows exponentially as time increases. Exponential function with a negative 1 over 100. Exponential function a is negative 1. Parabola function t squared. T to the 1 power, what's that look like? Square root of t. Sine of 1t, 1 radian per second. Cosine with 1 radian per second. A ramp multiplied by a sine function. A ramp multiplied by a cosine function. Ramps and sinusoids. And this completes selected formulas for 1 through 12. Functions 13 through 26. Top two are sinusoids and ramps. They all look similar. Sine wave that's phase shifted. How many degrees? Cosine function that's phase shifted. How many degrees? Hyperbolic sine is useful in transmission line theory. Hyperbolic cosine is useful in transmission line theory. Damped sine wave, useful in control system theory. Damped cosine function, useful in control system theory. Damped hyperbolic sine function, looks like a Zener diode characteristic. Damped hyperbolic cosine function. Damped ramp, common in control system theory. This is a step function. It has a value of 1 after t equals 0 and a value of 0 prior to t equals 0. When c equals 0 in this notation, it's the Heaviside function at 0. Whenever the Heaviside function at 0 is multiplied by any other function, it has the effect of zeroing that function prior to t equals 0 and leaving the function unchanged after t equals 0. In fact, every time domain function in the Laplace transform table is assumed to be multiplied by the Heaviside function at 0. Here's the Heavisided function at 0.5 seconds and the Dirac delta function at 0 seconds. It has a width of 0 and a height of infinity and an area of 1. Here's the delayed delta function to 1 second. And this finishes selected formulas from 13 through 26. Here is an example using the Heaviside function. It will be multiplied by the damped cosine function with a equals negative 1, b equals 25. After multiplying by the Heaviside function, c equals 0, we see that the resulting function has a value of 0 prior to t equals 0. Now the Heaviside from 0.5. 0 is the function before 0.5. Here are some Laplace transform properties. These are important in this course. This is the time-shifted function with Heaviside, function with Heaviside, function multiplied by the exponential function, integration of the function, derivative of the function, and second derivative of the function. This list is not complete, just the most common Laplace transform formulas. Notes 2, 3, and 4 may be useful in courses beyond this one. The S-domain functions have not been described yet. Let's describe the S-domain functions in the next video.